Calorimetry, specifically looking at combustion. Have you ever wondered how we get the calorie content of a particular food or substance? Well, this example here with our peanut butter, if we burn it and we combust it, it has to be filled inside a insulated container, has to be oxygen filled, an ample amount of it, and it has to be surrounded by water. Now, we don't always have to use water. As you can see in this case that we're going to be looking at, we don't use water. We only use the calorimeter itself and see the temperature change, increase of this calorimeter. Okay, but usually we look at it with water. So we have our Q is equal to MCT, our beloved formula. We're not going to be using our mass of water because usually we use this for water. We don't have it, so we'll leave it blank. So we only have the specific heat capacity of the calorimeter and the temperature change. So you get the product of that, it's this many joules. Okay, so it got absorbed, it gained this much energy. Well, where did this come from? Do you think it just came from nowhere? No, it came from the peanut butter. Well, how many grams of peanut butter do we have? We have 16 grams. So if we want to find the calorie content per gram of this peanut butter, we just get this energy that came from that combustion of peanut butter divided by the amount of grams, right, of peanut butter that we have in the sample. So if 1 gram of peanut butter, it releases this much joules. Well, we can just change this to 26.13 kilojoules. Why do we care about kilojoules? Because kilojoules is synonymous for kilocal. Kilocal is synonymous for calories. So for every gram of peanut butter that we got from the grocery store, it contains this many calories. We look at this question over here. We have an iron ring and there is no water involved. So it's just the iron ring that we're going to be using. We have this many grams of iron, and we're going to multiply it by the specific heat capacity. Where do I find this heat capacity? I found my specific heat capacity down here at the very bottom, 0.449 joules per gram degrees Celsius. So I'm going to be looking for my TF, right, because that's the one that I want isolated. If this is isolated and unknown, that means this one can't be unknown. I have to find the Q, right, the total amount of heat absorbed. Well, how do I find the amount of heat absorbed? Well, I have ethanol as written in the question. It's this many grams, and I just use my molar mass to find the amount of moles of the ethanol. I use my beloved formula here in order to find the total amount of energy that got released. Okay, not per mole, but total amount of energy released by the ethanol. So I'm going to put that all over into here. And again, this got released. However, where did it go? It got absorbed by this Q, right? So this Q is just going to turn it into positive. So this is now a positive value. I'm just going to put that same value over here. And then I have to just isolate for my TF. So this divides by this. So if I do it on the right side, I need to do it on the left side. So I divided it here, so I have to divide it here. And then of course my joules here cancel out with this joules, and this gram cancel out with this gram. So I'm just left with my degrees Celsius over here. Then of course I need to isolate for my TF. So I'm just gonna add it by 25 degrees. If I do it on the right side, I need to do it on the left side over here, as you can see. So I just add them together and I get 615.82 degrees Celsius.